Okay, so today we're going to go back and look at a lesson that kind of finishes something we did in 5.6, which is when we graph a line and then shade above or below. Well, 5.7, we're going to be graphing two lines. And a lot of times they'll make like an X shape, and then we're going to shade in one of the sections of the X shape. All right, so remember, we have to have our equations in a certain format if we're going to graph them. And we also have to remember what an inequality symbol is. Okay. How many different inequality symbols are there? Yeah? Yeah, there are 4 different inequality symbols. And we just went through them in the warm-up. So I don't think this is, yeah, you don't have to write that part down. That's just part of our review. Okay, 4 symbols are right here. And let's just make sure we know which one is which. Emily, how do you read that first one? Greater than. Yep. Brady, the next one.
Me?
Yeah.
Oh, greater. No, less.
Which one?
Less than.
That's a less than. Yep, less than. How about, let's see, Sean, how do you read the third one? Greater than or equal to. Yep. And the fourth one, how about, Alyssa, how do you read that one? Yep, less than or equal to. And depending on what symbol you use here, it's going to tell you whether you need to shade above or below the line, and you need to make the line solid or dotted. All right, so we talked about, probably for most of the third term, we talked about systems of equations. When we had systems of equations, how many variables did we have to solve for? There were usually, how many different things we had to figure out? Remember, yeah? 3. You could have a system of equations where you had to solve for 3 variables. We never did up to 3. We only did up to, remember how many variables we had to solve for?
You said 2, yes.
Yeah, we usually had to solve for 2, x and y. And that means if we were solving for 2 variables, we had 2 equations. Well, now we're going to do the same kind of thing, but we're going to have 2 inequalities. So we're going to have 2 things that have one of those 4 symbols in each column. So we have to have a set of 2 or more inequalities, and they have to use the same letters. So here is an example of a system of inequalities. We've got this, y is greater than or equal to 3, and y is less than 5x plus 4. That's a system. Got to have at least 2 for it to be a system. All right, what else? So let's see if we could just make up a system of inequalities. Okay, so you got to come up with 2 different inequalities, and they each have to use the same letters, kind of like the ones I just showed you in example 1 that we're going to do in a few minutes. So could somebody just make up some inequality? Let's put it in the y mx plus b form. But remember, it's not going to be an equals because it's an inequality. So what would be an example I could write down of an inequality?
Y is less than 3x plus 6.
Perfect. How did you think of that one?
I don't know how I thought of it.
You thought, yeah, you just make up anything, right? Y is less than 3x plus 6. Can somebody give me a different inequality? Yeah.
Y is less than or equal to 6.
Y is less than or equal to 6. Yeah. This is a special case. Remember, when you're missing one of the variables, it's special. It means it's either going to be horizontal or vertical. If you have both letters, it's going to be a diagonal, one way or the other. But yeah, that's a system of inequalities. So let's look at the steps for graphing a linear system. Okay, so first step, and this is number 1 on the guided notes. Each inequality needs to be in the form y and then mx plus b. It's not necessarily going to be an equal sign. It's going to be either a less than, a greater than, less than or equal to, or greater than or equal to. But it has to be the y and then the mx plus b on the other side. Okay, and it says that right below in your guided notes. There's not going to be an equal sign, but it'll be one of those 4 symbols. So, if your inequality looks like what I wrote right here, so you can put that after it says when it looks like, and then there's 3 dots, nothing needs to be changed in that case. Okay, so if it looks like this, nothing needs to be changed. If it doesn't look like that, so then it says, if not, recall, when it looks like something like this, okay, so that's what you want to put on your guided notes, that bold part. When it looks like 2x plus y is less than or equal to 5, then you don't have the x on the same side as the y. I mean, then you do have the x on the same side. You don't want that. You've got to get the x and the y on separate sides. So if we wanted to graph this one, could somebody tell me how I would get the y by itself? Yeah.
Subtract 2x.
Yep. You have to move the x to the other side by doing the opposite operation. So we've got a bullet you guys can write down. Move x. I wouldn't put 2. I would just say move x. Yeah, you could just say it like that. Move x after the sign. After means, in this case, on the right, by doing the opposite operation. Okay, so Abby said we'd have to subtract 2x. So we'll do that and then see what happens. What would happen on the left side if I subtract 2x? So, Abby, what would happen on the left side if I subtract 2x?
And moves so it's like behind this line.
So, yep, it's going to move. So what do I do on the left side?
Really move it to action as just y.
Yeah, it's just y, right? The 2x minus 2x cancels out. And all you have now is y is less than or equal to. And how should I write what's going to go on the other side? I want to make sure I'm putting it in this format. Mx could be plus b, sometimes it's minus b. How would I write what's going to go on this side? Yeah.
Y equals negative 2x plus 5.
Perfect. Negative 2x plus 5. If you say 5 minus 2x, you just haven't put it in the right order. So now if I was looking at that, Aiden, what's my slope there? 5 is something else. -2 is my slope. And if I wanted to make it a fraction, I would put what number in the bottom? Yeah, we could put a 1 in the bottom. So -2 is my slope. What about the 5? That's my, that's my y-intercept. Okay, I'm not going to graph that one right now, so we don't need to know that, but we're going to in the next problem. All right, and then the asterisk here, you guys already have that written. If there was a number attached to the y, all right, let's say you had a problem like 2y is less than 4x plus 10. Well, in this case, adding and subtracting is not how you get the y by itself. You divide everything by the number attached to y. So in this case, you divide everything by 2. Now, there's something that can happen here if you were to divide each side by a negative. Does anybody remember what you have to do if you divide by a negative? You're not dividing by a negative here, so you don't have to do it. But what if you were? Something is supposed to happen. Yeah?
With the inequalities.
Right. If you divide by a negative, you're supposed to take this sign and flip it. But in this case, you're not. So these would just cancel out. And you get y is less than 2x plus 5. Okay, so that's an example of if you had a number attached to y, how you get it. You divide. Okay, so that's step 1. Okay, just getting everything with the y by itself on the left side. Okay, step 2. We need to plot some points because we're going to get ready to draw our line. What's the first point that you would plot if you were looking at a problem like this? Or what's the first number that you would focus on? It tells you to use the M and the B, but which one would you use first? B. Yep, you'd use the B first. And remember, we're going to write this down. B again is my... Lexi, what's B? Yep, B is your y-intercept. So on the line that says B colon, you can put B, and then after the colon, just put B as the y-intercept. So what does the y-intercept tell you? It tells you when you're graphing, you already have the when graphing part printed. Just copy what's after the word graphing. Start at that number on the y-axis. So if your b value is 5, you're going to put a dot at 5. If your b value is 2, you're going to put a dot at 2. So it tells you where to put your first dot. And Mia, after I use B, what's the other letter that I want to look at? M, and M is my slope. Yep. So M is the slope. So on the line right below where you just wrote in B, it says M, and then after the M, put slope. It's the number with the X. So, for example, in this problem, the slope is 2. In the one above it, the slope is -2. A number that's with the x. So now the slope tells you kind of like directions from the y-intercept how to get to another point. And we already kind of did this in the warm-up, but you might want to write it down so you remember which way to go. Yeah. Yep, just saying. Okay, so once you get your y-intercept, you're going to write your slope as a fraction. If the number in the top is positive, you go up. If the number in the top is negative, you go down. You have a line right on the right-hand side, you can put those two things in. So those are the directions for the rise. Now, what word is going to be underneath rise? That's going to be in the bottom. Run. And what are the two directions we can move for the run? It's not up and down, the rise. It's left and right. Yep. So it's exactly what I did in the warm-up with you guys. So if the number in the bottom is positive, you're going to move to the right. If it's negative, you're going to move to the left. Okay, so a lot of steps just to kind of write down at the beginning, but then we'll get into some examples. But pretty much the whole front of the guided notes is the steps, and most of it is review. Okay, so after you finish step 2, you're going to have something like this on your paper. You're going to have 2 dots. What do you think we're going to do now since we have 2 dots? What was the whole goal of figuring out those 2 dots? We're trying to... Okay. So we already know the slope. That's going to be given. That's going to be the number with m. So we use the slope. We use the intercept. We got 2 dots, but now we want to graph it. So we want to draw the line through those dots, and that's step 3. Draw the line through the points. And what we're going to do today, I kind of hinted at this in the warm-up, we're not going to shade right away because we're going to have to shade in a certain area in like an X shape. So what we're going to do is draw the line. We'll talk about whether it should be solid or dotted. That's in the chart that's down below. But if you were supposed to shade above, in this case, I would go like this. Just put arrows pointing above. Don't actually shade it in. Just kind of point where you would shade. And now remember, we're going to be solving a system. So that means how many lines are we going to have to draw? Caleb? 2. So step 3 is basically draw the first line. Well, step 4 is do it again. Do steps 2 and 3 again for your second line. So now when you get to step 4, you're going to have something like this. Maybe one of the lines is shade above. And maybe the other one is also shade above. And what we're going to look for is where they overlap. If both of them were shade above, that means you've got to find the section in that X shape where you're above the black line and where you're above the red line. Well, that would be like right here. That's the section where you're above the red and above the black. And that's the answer that I'm looking for. You might think, well, what about right here? Well, If you're in this section, you are above the black, but you're not above the red. You're underneath the red. Okay, so if the problem said you had to be above both, well, then you have to be above both. You can't just be above one. And I think that's what step 5 is. Where the arrows overlap, shade that area only. Now, the last thing it says is if there's no overlap, then there's no solution. Well, how could you get no solution? Well, in an X shape, you can't. If they cross in an X shape, there always will be a solution. But besides being in an X shape, I mentioned another way they could look. Does anybody remember another way I said the lines could look besides being in an X shape? Yeah? They could be parallel. So now, imagine you had a line like this and a line like that. And I said to you, you need to shade above the top one and under the bottom one. Is there an overlap there? No. There's nowhere that I could put a dot that would be above that one and below that one at the same time. Now, if it was reversed and it said shade below the top one and above the bottom one, well, then I'd be sandwiched in the middle. That would work okay. But that's an example of a no solution. There's no overlap between those areas. And generally, a no solution for us will only happen, could happen, if you had parallel lines. Okay, so those are the 5 steps. Okay, it's pretty similar to what we did in 5.6. The only extra thing here is step 4, where you have to draw a second line. That's the only extra step. Even the tables down below, for the regular cases and the special cases, those are going to be the same. All right, so let's talk about our tables, which we kind of already did. If you had a less than symbol, what would your boundary line look like? Solid or dotted? Yeah. Yep, this would be dotted. And for a less than, would you shade above or shade below? Yeah. Yep. So this is dotted and below. All right, let's look at the next one. Less than or equal to. Solid line or dotted line? Yeah. That's going to be solid because it has the equal to. And would it be a shade above or shade below? So it's solid and below. Yep. Solid and below. And if you make a mistake on Elastic when you're drawing it, it's supposed to be dotted instead of solid or vice versa. You can just click clear, reset it, and just do the problem again. Okay, how about greater than? Solid or dotted? Yep. That's going to be dotted. Above or below? Yep, dotted and above. Perfect. And what about greater than or equal to? Yep. Solid and above. Yep. Solid and above. Yes. Yep. Now, as long as you have a problem that looks something like a Y, one of these four inequality symbols, and then an mx plus b, it's going to fit into this table. Which one of these four symbols you'll have, well, that's going to control whether you make it solid or dotted, and then shade above or below. But there is a special case, two special cases. This is not a special case. That is not a special case. Does anybody remember, how do we tell if it's a special case? Yeah.
It only has a Y in it.
If it only has a Y or an X, yeah, it's only going to have one of the letters. Okay, so let's say you had only a Y with no X. Okay, here's an example. Y is greater than 3. Does anybody remember what kind of line you get if all you have is a Y? Yeah?
Line goes straight across.
And that would be, how would you describe it if it goes straight across?
From left to right.
Left to right. Yep, it's going to be horizontal. Okay, it's going to go across. Now, if it goes horizontal, the shade above, shade below still makes sense. If it's less than, this is above. If it's less than, this is below. If it's greater than, that's above. So there's no issue with that. But we've got to talk about this second one. What if you had an X with no Y? Like this one. What kind of line would that be? Just an X with no Y. Yep. That's vertical. Now, when you draw a vertical line, there really is no such thing as above and below. Okay? Here's a vertical line. You don't have above and below. You have, well, what do you have in this case? You could either shade to the, or to the, yeah.
Left or right.
You either could shade to the left or the right. So when you have a vertical line, less than or equal to, shade right. I'm sorry, shade left. Shade left. Less than or equal to, you shade left. You basically shade the way it tells you to, with the way it's pointing. If it's a greater than or equal to, shade right. This is the only case where shade above and below doesn't make sense. Because you don't have above and below. Okay, so those two tables, that covers, and those are from 5.6. We've done those tables before. But that covers all the regular cases, and then all the special cases. There's that. Any questions, or does anyone need to still copy anything down from the tables? Okay, so now we'll just practice some sketches. There's two ways I can give you this kind of problem. Okay? I can either give you a system and then ask you to graph it, or I can graph it for you, and then you tell me the system. So this one is a little bit different. This is kind of where the overlap would be. They just show it as a darker area. And you'd have to kind of work backwards and figure out these two lines. Well, one of them's a special case because it's vertical. But we'll we'll see if we get to that one, and we'll talk about how to do it. Okay, but first, let's go through some where you have to graph. Okay, so it says graph the system of inequalities. And then it says once you graph it, write a coordinate that is a solution. Now remember, a solution is anywhere that's in the shaded area. So you could pick anything in the shaded area and it'll work. So we have lots of different answers for the second part of this problem. Okay, let's start with the first one. We'll call this inequality 1 and 2. Is inequality number 1 a regular type problem, or is that a special case? What do you think? Yes? It is a special case because we only have a y and we don't have an x. When you only have a y, what kind of line is it? Yeah?
Horizontal.
Yeah, it's going to be a horizontal, and they tell you what number to put it at. What number are we going to put our horizontal line at? Yeah, 3. So we're going to put a horizontal line at 3, but before I draw it, I need to decide if it's going to be a solid line or a dot. Yep. Yep. It has the equal to, so it's going to be a solid horizontal line at 3. So basically, just going to go like this. And now, I'm not going to start shading it all in. I'm just going to point where I would shade. So, would this be a shade above or a shade below? Yeah. This is above because it's a greater than or equal to. So again, don't actually shade. Just point which way you would shade. Okay, you'd shade above. Okay, we're not shading it in yet because we still have another line we need to draw. Okay, let's look at the second one. Is the second line, I did this one in black. I'll do this one in red. Is the second line a special case or regular case? Yeah. This is a regular case. Okay, so it's going to be on a diagonal. What number do we focus on first when we want to graph y is less than 5x plus 4?
B.
Yep, b. What's the b value here? 4. 4. That's my y-intercept. So go up 4. And put a dot. Oh, that's not my axis, I'm sorry. Start from your axis. That's my x-axis. That's my y-axis. Go up 4 and put a dot. 1, 2, 3. There's my dot. Okay, so I looked at B. Emily, what's the next number I need to look at? The slope, which in this case is 5. And Joe, I need that slope to be a fraction. So what number can I put underneath it?
1.
Yep, put a 1. And who can tell me from the red dot, which way do I go to get to the next red dot? 8?
Go up. Or you go to the right.
We're going to do both. I just need to know how many.
Go up 5.
Up 5.
To the right.
Right 1. Yep. So up 5. 1, 2, 3, 4, 5. Right 1. If you want to do it backwards, we can go the other way. 1, 2, 3, 4, 5, and 1. Again, once you get 2 dots on edge elastic, that'll be enough. It'll draw the line for you. Okay. Before I draw it, should it be solid or dotted? Yeah?
Dotted.
This is done. So what I'm going to do is I'm just going to draw it solid, and I'm going to change it to dotted using the program after. Okay, so there's There's my line. Just put it where it should go. Right about there. And make it dotted. Okay, so now that's dotted. And should I be shading above or below for number 2? Look at this symbol. Yeah?
Wouldn't you go to the side? Like across? Like opposite to the left?
Well, it's not a special case. It is a regular case. So we have to think about where do we shade if you have this symbol in a regular case. Where does the chart always tell us to shade? Yeah? Below. It's a less than symbol. It's a regular case. Less than means shade below. So below, I said I would do it in red. Forgot to make it red. So below that line is going to be here. So that's below the red line. And we have to be above the black line. So where am I going to end up shading? Can someone describe to me, where am I above the black, but under the red? Yeah?
Top right.
Yeah, it's like in the top right. So if I just use my highlighter, this is the area that's below the red and above the black. All this area right in here. And again, it doesn't have to be perfect, but that's the area where you want to shade. And that's why when I just drew this horizontal line at first, I didn't shade in this whole thing above the horizontal because it's not everywhere above the horizontal. It has to be above and to the right. So any questions on that one? That's like the kind of the typical case. You don't have to rearrange anything. The variables are already set up for you, and we're good to graph. Okay, let's try this one. Okay, I like the second one, but what's wrong with the first one this time? Yeah. Yeah, the 2x is on the wrong side. So can someone tell me, how would you put this 2x on the other side? And that's the very first thing we have to do. Yeah.
Subtract 2x?
Yep. We're going to have to subtract 2x from each side. And now we've got y by itself. What would be on the right side if I subtract 2x and then put it in the correct order? Because remember, we want to have it like mx plus b.
Negative 2x plus 3.
Yep. So negative 2x plus 3. So we want to use that one and that one. No special cases this time. So we're going to have 2 lines on diagonals, and we're going to see where they cross. Let's start with graphing the first inequality. What's my y-intercept for the first one? Yeah, 3. So we're going to put a dot at 3. All right. So I got that. What's my slope for the first one? Yeah. Yep, and let's make it a fraction so we have the rise and the run. What would you put in the bottom?
Over 1.
Yep. So from the dot that I just made, which way am I going to go to get to another point? I'm going to go, yeah.
Down to right.
Down to right 1. And we got enough graph paper, we could do that a few times. It's enough. Now we'll make our line. Solid or dotted?
Dotted.
This is dotted. Yeah, this is going to be dotted because it's a greater than symbol. So I don't have a good way to draw it dotted. I kind of have to change it after. But that's all right. So just put that in. I think you have to do it the same way on Edge Elastic. You have to draw it solid, and then you can click on it and make it dotted. Okay, and one more thing we want to mark here before we go on to the second one. Where am I shading? Above or below? Yeah, above. That's a greater than symbol. Don't actually do the shading, but just put an arrow or a few arrows telling you would shade above. That's above. Okay, now we're going to do the second one. Anaya, what's my y-intercept there?
-3.
What is it?
-3.
Yeah, so put a dot at -3. And the slope is already a fraction this time. So how am I going to get from that dot to another dot? Which way are we going to go? Yeah? We're going to go up 1, right 3. Up 1, right 3. Up 1, right 3, up 1. You don't have to do it that many times, but there we go. Is that going to be solid or dotted? Yeah. Yep, it's going to be dotted. So again, I'll draw my line. That's a little off on that one. My line right there. Make it dotted. And I'll make that one red so we just know it's the different one. And am I going to shade above or below the red one? Yeah. Yep, we're going to shade above. So now we've got to find the area that is above the black and above the red. Where would that be in our X shape? Yeah. Yeah, it's like the top right again. So you don't have to use a highlighter. If you have a pencil, you can just kind of go like this. I can tell that that's good enough. Above the red and above the black. Perfect. Any questions on that one? All right, so I think let's skip to number 5. We didn't get to 3 and 4. What we can do, since we do have half a class tomorrow, I can go through 3 and 4, and then we can review the homework as well. Let's try 5. All right, I'll put that up. So this is the direction for number 5. It has 2 steps. And you're basically working backwards now from a picture to figure out the 2 equations. Well, the first step is to figure out, is it going to be a regular case or is it going to be a special case? You'll know it's going to be a special case if it's horizontal or vertical. If both of the lines are on diagonals, then that's a regular case. If it is a regular case, there are 2 numbers you need to figure out. First thing you need is the y-intercept, and you can get that by looking at the graph and seeing where it crosses the y-axis. And this part, you guys have really already written this down several times. You don't have to write it if you don't want to. Actually, you've written this too. So you've got to figure out your y-intercept, and then you have to find the steepness of the line. That's the slope. Well, the slope is easy because you can count. Remember, if your line slants this way, that's a positive slope. If it slants that way, that's a negative slope. But you're just going to count the rise, and you're going to count the run. And then the last step, when you're writing your inequality, is you look at two things. If the line is solid or dotted, that's going to tell you something. And then if you shade above or shade below, that's going to tell you something else. So those are the two things you have to look at. Is it solid or dotted in step 2? Did you shade above or did you shade below? And the chart that you guys already filled out is going to help you to get that in. Yes, I'm going to try to leave that up there while we do the last problem. I'm going to make this one red, just so you guys can see it's a different one. And this other one is the black. Let's start with the black one. Is the black one a regular case or a special case? Yeah. That's a regular case because it's on a diagonal. So we need to figure out a slope and an intercept. It's definitely going to have a y because that's what a regular case looks like. What's the y-intercept? I think you have it on your notes too for the diagonal one. Yeah, 2. Okay, so we're looking for something like y equals mx plus b. So b is 2. Now we need a number that's the slope. We've got to fill this in right here. Well, to get the slope, you've got a dot here. You've got another dot here. Count the rise and the run. To get from this black dot to this one, do you go up or do you go down? Yeah? Go down. How many do you go down? 1, 2, 3. Down here? 2. So down 2. And then right, how many? Yeah. There's your slope. Down 2, right 3. You just count. So put that number in front of x. And now this is a solid line. And look at where you ended up shading. That was the final answer. That's a solid line, and you've shaded below. What inequality symbol represents solid and below? Yeah. Perfect. Less than or equal to. And now the red line is a special case. Even though it's a special case, that one's actually easier. Is it vertical or horizontal? Yeah. Vertical. And what letter is always by itself on the left for vertical? X. Now, what number does the vertical line go through? Yeah, 3. And we've shaded to the right of the vertical line. What symbol would mean to the right in a special case? Yeah, greater than. Perfect. So might need a little more practice with those, but that's how you work backwards to figure out your inequalities.
So, Mr. Hager, the x is greater than 3, is that a solid line or a dotted line? So, yeah.
Yeah, thank you. That should have the equal to under it because it is a solid line. If it was dotted, we could have left it as a greater than. But yes, thank you. It should be greater than or equal to. And the homework tonight is 5.7. I'll see you guys tomorrow.